Hi, this is Jeff Spence, your statistics instructor for the Community College Denver, and this is a video covering a particular topic about the bell-shaped distribution called the empirical rule. So let's be clear on what we mean by the empirical rule. Starts here by saying if you have a distribution that is normal, sometimes called bell-shaped, and then it tells you the rule. But let's just go back over what a bell-shaped distribution even is. So remember when we organize data and we create a histogram from, say, the table of that data, the frequency distribution, and then potentially the relative frequency distribution, we create a histogram where if we were to fit a curve to it, it would look pretty symmetric and bell-shaped, meaning most of the data is in the middle, and there is an equaling lower amount in the right and left direction. So this is an example of one that I just found on Google. Here's some other ones where it kind of shows, if you were to fit a curve to it, it basically fits what's called a bell shape. Now notice that no distribution is perfectly like this one here. This is just a hypothetical one where it looks basically perfectly symmetric on both sides. But most distributions are kind of like semi bell shaped. Nothing fits it exactly perfectly when you actually organize data. But the idea is that after we look at the histogram, we can say, oh, that's about a bell-shaped distribution. And if we have a bell-shaped distribution, then we can use these specific rules that come from calculus for approximations for the distribution that we're using. So for instance, on any bell curve, meaning a curve that fits this shape, okay, we know that approximately 68% of the individuals in that distribution are within one standard deviation of the mean. So when we say within one standard deviation of the mean, we mean from one standard deviation below to one standard deviation above the mean. 68% of the individuals are within those two values. Then it also tells us, I'll get to the percentages down here. That's the whole point of this video, but I'm just going over the general empirical rule. The second part of the rule tells us that 95% of the observations, 95% of the individuals, are within two standard deviations. So obviously, if we go further out, we're picking up more of the individuals. So we go from 68 to 95. And then if we go out to three standard deviations, we have 99.7% of the individuals or the observations, which is pretty much almost everyone, but not everyone. Okay. So the main point, really what this is showing is just the specific percentages. Like obviously we know when we look at a bell curve that most of the individuals are close to the mean. Now we know that 68% are within one standard deviation, 95% are within two, 99% are within three. And we know now specifically these percentages, the 68, it's sometimes called the 68, 95, and 99.7 rule. All right, now the second part of this video is to explain to you how these percentages are presented. Like, how did they come up with these numbers? So I'm going to show you a little bit of the math here on this video. So as we can see, since the bell curve is symmetric, the right half is equal to the left half. That's going to be a key fact that we're going to use and need to know as we do these calculations. So I think it's pretty simple. The first two percentages are pretty straightforward. If we have 68% within one standard deviation, then the right half is equal to the left half. If we just take 68, oopsie, and divide by 2, let me zoom in a little bit now. 68 divided by 2, we get 34% on either side. Now what this means is that 34% of the individuals are from one standard deviation below to the middle, to the mean. And 34% are between the mean and one standard deviation above. So we know these two values, but how do we get the next ones? It's a little bit more complicated, okay? So we already have 68% accounted for here with the two 34s. Next, when we go from 68 to 95, we need to figure out, well, how much percent did we add? So in order to do that, we just do 95 minus 68. That's 27%. But 27, so when we go from one standard deviation to two standard deviations, or within one to within two, we're adding 27% more. But remember that 27% is split into two equal halves. So we take that 27%, the two equal halves are because the bell curve's symmetric, and that's how we get, when we divide 27 by 2, we get 13.5%. That's how we get these two values. So what this tells us is that 13.5% of the individuals are from 1 standard deviation above the mean to 2 standard deviations above the mean, or 1 standard deviation below the mean to 2 standard deviations below the mean. Next, as we jump from 2 standard deviations, within 2 standard deviations to within 3 standard deviations of the mean, we go from 95 to 99.7. So how much percent did we add? 99.7 minus 95, 4.7%. But remember, that's in two equal halves, the lower and the upper half, so we divide that by 2. And that's how we get the 2.35%. Here and here. So what this tells us is that there's this is a small chunk, 2.35% is between 2 and 3 standard deviations. And as we can see, the height of this curve is not very high, so it's a small percentage there. And same thing down here, 2.35% below 2 standard deviations to below 3 standard deviations. And then lastly, the last bit, remember 99.7 is not all of it, 100% is all of it. So we don't have 0.3% accounted for. So when we do 100 minus 99.7, that's the 0.3 that is not accounted for here, 0.3%. Then we need to divide that by 2, and that's how we get the 0.15%. I want to be very clear about this. This is 0.15%. This is not 15%. 0.15% is less than 1/4%. 1/4% is 0.25%. So this is a very small amount. In other words, to find an individual that is more than 3 standard deviations above the mean, anything more than 3 standard deviations, we don't care about 4 or 5. It's so small that we just stop here. And 0.15% of the individuals are more than 3 standard deviations above the mean, or less than 3 standard deviations below the mean. Okay, so this particular percentage is very small, but it still counts. And if we add up all these percentages, it will add up to the 100% of all the individuals in the curve. So one thing I recommend is when you do empirical rule problems to have this picture ready. Or if you feel like you're comfortable building up these percentages, you can do that as I've shown here. And you could just have the written rule of 68 within 1, 95 within 2, and 99.7 within 3. But as I do examples in the future, I like to have these percentages available so that I can figure out the percentage, say, above, below, or between any two values by just adding these percentages. Okay? And then the other main thing that you're going to use, so basically an example that we would do on this is we would give you values of the mean and the standard deviation, and then you're going to put those values down here and answer various questions. I'll show that in the next video, or another video, excuse me. But that's it for this. That's how this picture is set up, or created, excuse me, using these 3 facts from the empirical rule. So we'll see you next time.